Okay, today we're going to be looking at 5.4, the fundamental theorem of algebra, and basically we're going to be counting the number of x-intercepts, finding the degree and the y-intercept. So as you notice, this polynomial given for question 1 is already broken down into linear factors, x plus 4, x minus 1, and x minus 2. The degree is going to be come from counting all the x's, or basically the highest x. Normally you might have something that was written out like x to the 5th, and then maybe something x to the 4th, 4x to the 4th, and it'll just continue to go down until you get to like a constant, like maybe minus 6. So your degree is the highest exponent, or the highest number of variables you have in one term. But because the function that we're given here is not already multiplied out, we are basically going to need to count. So this term right here says we have 2 x's because of the exponent 2. So all we need to carry that 2. And then since we're multiplying, that means it's going to be one term. We now have this term which has 5 x's, so I have to add that. That's adding to my degree. And this last one only has 1. There's no power, so it's understood to be a 1. So I have to do 2 plus 5 plus 1 when it's written in linear form, and this gives me 8. So if you were to multiply this out, you would get a polynomial of degree 8. Okay? The y-intercept is going to come from the constants. So you're going to take those constants, which we have is 4 in the first one, but it has a square on it, so we're going to do 4 squared. And then the next one we're going to add is going to be a negative 1. That negative 1 is raised to the 5th power. Okay. And then last we have a negative 2. And I'm not sure why I wrote plus. Again, all of these are being multiplied together. So we need to find each of these values and just multiply them. So 4 squared gives us 16. Negative 1 to the 5th is still going to be negative 1. And then negative 2. So when we multiply this, this becomes a positive 2 times 16. That gives us 32. So that is going to be the y value. They want us to write it as an ordered pair. So notice this is the y-intercept. So ordered pair, x is 0, y is 32. That's always the case when we're dealing with y-intercept. So as an ordered pair, we're going to do 0, 32. So, alright, this is step 1 of 3 parts. Okay. Now we're going on to step 2. Step 2 wants us to find the x-intercepts which the f crosses the x-axis. Okay, so if we were to graph this, we would have at most 8. But look at the power. The power is going to tell you which ones cross. So odd exponents cross. If it's an odd power, it crosses. Okay. Power is greater than 1. Anything greater than 1 will flatten out, because part 3 is going to ask which ones flatten out. Okay, so we got 2 cases. Right now we want to know which ones cross. Alright, so this x plus 4 has an even power, so it will not cross. It will kind of flatten out or do a turnaround. X to the 5th is odd, and this x minus 2 is to the 1st power is odd. So we have these 2 that will cross. So we're going to say 2, and they're going to ask you which ones. Okay, so it's the x minus 1 and x minus 2. The way we tell them that is we set those numbers equal to 0, x minus 1 and x minus 2. set them both equal to 0, and solve for x. And so we're going to add 1, and that gives us x equals, sorry we can't see that, x equals positive 1, and we will add 2 here, and that will give us x equals 2. Alright, so are we asked to write it as in, express intercepts as ordered pairs? Okay, so now we're given x value, so the y is 0. So 1 comma 0, and then we'll have 2 comma 0. And now step 3 wants to know which zeros flatten out. Okay, so again, if it's greater than 1, it's going to flatten out. So the 2 that have powers greater than 1 are the x plus 4 and the x minus 1. So again, we will solve those, set them equal to 0 to find the actual x value. So subtracting 4, we get x equals negative 4 as an ordered pair, negative 4, 0. Add 1 as an x value, we get x equals 1. As an ordered pair, we get 1, 0. So these will be our 2 that flatten out, and the actual values as ordered pairs are negative 4, 0, and 1, 0.